the interrupt section well. Most of the job we have done yesterday. Today lecture really is not much more difficult, and you can learn it very fast, I'm sure, and you will enjoy. Even I do something new, which maybe you will not find it easily in any book. Uh, the last part that I will tell you today, this is exactly based on my experience and working with the Arduino board, and I'm sure that you will not find it easily in any book, but no problem. Purposefully, I give it to you to enjoy it and use it in your project, um, because this interrupt part will help you more in future study and work. After this part, we will work to we will start to work on some actuator part like DC motor, servo motor, and most probably stepper motors. What I plan till next week, this time we will finish the servo motor part, and um, let us see what will be the future program from our school. um, I think till now we cover most of the part of Arduino. Some timer part will remain that I'm thinking to have some maybe short lecture or some extra lecture, I don't know, about that timer part. That that time I can say that all the parts from Arduino boards are uh, covered perfectly. Okay, let us see what is today. Today is Interrupt and ISR 02, which especially and specifically we are going to concern regarding the Arduino feature. Okay, let us start from this example. I call it example number one. In example number one, we have this situation. I have one button which is connected to digital pin number 2, and the one LED which is connected to pin number 13 of your Arduino board. You know that really, in the real world, we don't need to put this LED on Arduino board because it's available on our board and no need to put any extra hardware. But just to show the figure, I have put it here. You will see that um, the simple sketch I'm putting here, one push button in order to toggle the state of the LED, and turning on and off it. When I push it and press it, it should on. When I don't press, it should turn off. Let us see how should be my program. Okay. Program is very simple. As usual, first I should specify which pin is LED, which pin is my key, which I have put it here, constant int LED pin number 13, and button pin, which I call it number 2. But after that, I should initially put some state for my LED as well as my key, which because I want my LED, my key work, first I will put the LED toggle as the low, means the initial state, and I call the previous state as high, and then one variable I will define as the bottom state. Then in the setup mode, first I will say that what is the pin LED act, which I call it pin number 13 as the output. And then we will put for the pull up for the button, which already we talked, why we use input pull up for the button in the setup section. Then in the loop section, first I'm going to read the state of my key. How we will do? We will do the digital read and P. I want to know what is my pin uh, state. And then I will check if my bottom is low, means that it's pressed, and also previous state is high, means that I should check that previous state is high. Then I will toggle the LED mode, means that if it's on, I will put it as low. And if it's low, I will put it on. And again, I will put the digital right as the LED toggle. Means that the reverse mode that we have, I will load on the LED. And then I will define the previous state as the bottom state that just already I will read. And then some second I will wait and then continue. This is one method, but as you see that it's not very good. It's work, 100% it's work. But you see the number of lines that are written here. How many parameter I defined here? Okay. Somehow we can say it's not good because it make my program lengthy. And I'm sure that it will take a lot of time from my CPU to process and or even work. Then what we can do, we should do some optimization in our code or using some method that save the method. That method we call it interrupt. Okay. And this method we call it pooling. Because as I tell you, the meaning of word pooling is that it's pull, it's hanging. Okay. It's hanging my CPU. It's pull my hanging. It's overload my CPU. Now I want to have the method that just don't overload it. I want the method that it's make it free. Okay. That method we call it interrupt. Let us see how we can solve. In this scenario, the Arduino, I mean the Atmega 3 to 8P controller is to be specified. Keep on checking for the state of my bottom in the loop function. And in the method of pulling, it's checking whether the device or pins need service from the processor, like the microcontroller, and we call it pulling. The main problem with approach is that the controller should continuously engage in activity or checking the state of the bottom in this case and cannot perform any other task. Here is the exactly the meaning of the um, interrupt that we are searching for that and we want to describe for you. Means that instead of using this much variable, instead of using this much mm, word load on our system, maybe we can use the interrupt, which will be more faster and better. Let us see. If I want to use the Arduino interrupt, let me review once again yesterday lecture for you. We have one interrupt function which is already available in our Arduino IDE means that we don't need to add any other library for this job. And by this, we can initialize the Arduino interrupts and with which pin Arduino you want to initialize it. Attach interrupt function is used for this purpose, and this function takes two arguments as a pin. One is the pin numbers to which pin you want to use the external interrupt triggering. The format is like this: attach interrupt digital pins, pin, ISR, and mode, which I tell you yesterday. We have another method that we can use. The second argument is function name to which you want to call upon every interrupt. And last argument is the type of the interrupt that you want to have. Example is something like that. Attach interrupt, digital to interrupt or pin is pin number 2. Don't forget pin number 2 and 3 are assigned in ONO for the external interrupt. And interrupt function is the function that we are going to see. You can put any name that you want, your name, my name, class name, anything that you want as this part. And third part is the mode that we should talk today more about it. When the event or interrupt will happen, the processor takes immediate notice, save its execution states, run a small chunk of the code, often called interrupt handler or interrupt service routine, and then return back to whether it was doing before. The programmer defines the code that is to be executed when a particular interrupt occur during the program itself. In Arduino, we use the function of attach interrupt to do this job with this format that I tell you. Once again, we will review. First parameter is pin number. Second parameter is location of the code. And third parameter is the type of the trigger that we want to see. Okay, the interrupt vector is determine what pin can be used. This is not the number of the pin itself. It's actually refer where in the memory the Arduino processor has to look or to see the interrupt occur, and a given space in the vector correspond to the specific external pin, and not all the pin can generate an interrupt. On Arduino Uno, as already I tell you, pin number 2 and 3 are capable for doing this external, and they correspond to the vectors number 0 and number 1 respectively. For the list of the pins, you can check out there's some documentation of attach interrupt. That last lecture we talked about it, and I tell you that what's the difference between the Mega Uno and 101 interrupts external pin and how people can use it. Maybe some of you still are confused about the function name as the third part of this syntax. I should tell you that this function name of interrupt service routine determine the codes which goes and run the interrupt condition is met. Means that it's something like we'll address the subroutine that we want to jump through that and do the interrupt job, or the task that we hand over to the interrupts through that. Important part in my point of view regarding the interrupt is this interrupt mode. Interrupt mode, which will determine what pin action trigger an interrupt, or the Arduino Uno supports four interrupt mode. We have rising, which activates an interrupt on rising edge of the interrupt pin, falling, which is activated on falling edge, change, which is going to any changing, and low, which is just low. Just to recap, our setting of interrupt is setting up to the monitor interrupt vector number 0 as pin number 2, and to respond the interrupt using pin ISR, and to call this pin whether we see any change on pin number 2. Let us have the better look to this mode. Uh, Suppose I have these pins, this waveform on some assigned pin, pin number 2 or pin number 3. We want to know what is rising. Rising exactly is like this. I'm go from low to high. If I go from low to high, I can say my mood is uh, in rising. What about falling? Falling is reverse. I should come down from high to low. Change is any change from low to high or high to low. Any of these circle parts that I put for you or assigned in these pictures is showing me the change. And what about low? Low is exactly just this part that you can see. Low are these part. Okay, we polish yesterday lecture till now. Let us come back to our question and see that as the example two, if I want to have the optimized code or I have the less number of the line for my code, what should I do? How I should do the programming part? It's simple. You will see. I show it in program number 2. Same question I have. I have one key which is connected to low as well as pin number 2. I have one resistor and one LED which is connected to pin number 30, and by that I want to have the action whenever I press the pin number 2, it should blink or it should turn on and off. Let us see how I solve this problem. Simple. Again, for the first line, I set some variable as the pin number 13 and bottom pin as pin number 2, but I put LED toggle number low. If we compare this part, you will see that 2, 3 line I cut, means that no need for that. Then in setup, as usual, I specify what is my input, what is my output. My output is pin number 13 as the LED and pin number 2 as my key. And now the next line is attach interrupt syntax, which in that I say that digital pin to attach is bottom pin or pin number 2. For the function part, I put the bottom ISR that is at the below, and the mode is change. Means that whatever, if I go from high to low or low to high, my LED should act or toggle. Okay. Nice thing is here in my loop. Please have a look. Here in loop, I don't have any part. But instead of that, this is the interrupt routine. I have the function or some line, which in that I say that LED should toggle and have the toggle mode. And after that, write the toggle mode to my LED. You will see that this program, its number of line is less, firstly. Secondly, the speed is also much more than previous example, means example number 1 that we had. Both of the program are working. Please don't forget. But program number 2 is optimized one and most professional one. Also, if you have lots of work to do in your loop, then simply this can work. Means whenever any person press the key, then you will see that the action will happen. This you will enjoy when you uh, do the simulation or task for this job, um, and send it for me. You will see that. Okay, let us see little bit more or uh, check some more condition. Think that again, I'm going to tell you the bottom interrupts example, but now it's in another method. First program that I show you that was in pulling mode. This program is also in pulling mode, but the difference is that this is the example that they put in the IDE, and this is in pulling. That, but little bit number of code is less, but you will see that I can use the if and else condition to do the same job. This is, you can find it in Sketch and check out from the bottom. Some few changes between the codes we have. The first and the most obvious things is that in the loops of the interrupt codes, we don't have any structure and we can get away with because of the work. I mean, in the loop part of the interrupt, there is not much more uh, codes. This is nothing. Even that delay can be removed simply. But what we use some pin ISR. This type of function is interrupt service routine. Its job to run quickly and handle the interrupt and let the processor get back to the main. Means if you push the key, it will have the action in interrupt. If you don't do it, it can do the regular job. Suppose we can have some example that I will show you at the end, that in serial printing, you will do some job, you will print some variable. And whenever you press the interrupts, then it will go and do the proper job. There are few important things in interrupt code that you should consider when writing the service routine. First, Please don't forget the ISR, or the function that you are writing in your ISR mode. It should be short and sweet. You don't want to return the main loops for too long. And there are no inputs variable or return values. Means that it's better that you don't send value to the interrupts and come back. All change have to made on global variables. You are probably wondering how we know an interrupt gets run or what trigger. The third function in setup routine is what set up the interrupt for whole system that we need. One more quick things that you should remember are ISR uses the variable uh, bono state to store the pin state. If you check the bottom state or definition of the bottom state instead of type int, we define the type of volite int. Volite, as you know, in C keyword applied to variable, it means that the value of that variable is not entirely within the program's control, and it's reflect that the value of bottom state could change and change on something that program itself cannot predict. In this case, user input, one more useful thing is that the volite keyword does it protect us from any accidental compiler optimizer, and compiler as it turn out have a few purpose in addition to turning your source code into the machine execute. One of their tasks is to trim the unused source code variable of machine code. And since the variable bottom state is not used or called directly in the loop or set of sanction function, there is the risk that compiler must remove it as an unused variable. Then don't forget why we use the volite int. And the volite int is one of the practical points that I tell you uh, today I will describe. Besides, volite keyword has some side effect of telling the compiler to cool, and it just and hang to the variable. It's not a fat finger or something like that. But anyway, it's good to remember. Okay, now before I go for the um, near to the end of today lecture, well, let us first review what I tell you till now. Till now, I tell you that if I want to have the fast programming to sense some external event, Arduino give me this chance to using two pin in Ono, which we call it pin number 2 and pin number 3, which in this two pin, some external event can sense. Okay, and how I should use this? It's very simple. There is one syntax for interrupt, which in that I need to specify the pin as the first part, the function name that or part of the program that I want refer to and do my task. And third part is mode. Mode, as we say, we have three modes of change: high, low, rising, and falling, something like that, which we can use as the mode. And simply, I can use this. This is the whole summary of yesterday and today lecture. But now I want to give you one example which I have done myself. This is some 100% practical job that maybe you will not find it anywhere. If I want to check two interrupt mode at the time, means pin number 2 and pin number 3 at the time. What should I do? Okay, one pin checking is not much more difficult, my friend. Even two pin checking is not difficult. This is something that I have done. You will see that. First, we will do some running Boolean volatile variable as false. Second, I will specify, suppose I have two switch. Switch number 1 is connect to pin number 3. Switch number 2 is connect to pin number 2. And then I'm going to check. When you want to send me this task as example number 4, I want that you draw the circuit diagrams, and then I will understand that you understand or you know the coding or not. Okay, that is why I didn't put any circuit diagrams here. Okay, in the setup mode, first I specify the serial monitoring, then I specify the switch number 1 mode, as I call it, input pull up, switch number 2 or pin number 2 as the pull up. Then I specify two interrupts. Interrupt number 1 as switch 1, I put the function of turn on, and then my mode is falling. Interrupt number 2 I use for function turn off and falling. What does it mean? It means that if I press the pin number 3, my LED will turn on. And if I press pin number 2, my LED will turn off. Okay. Now see, in void loop, I do something. Just I take be happy, something like that. Whenever I will press the pin number 3, you will see that in serial it will return yes, and whenever you press the pin number 2 in serial, it will press no. This example, I put it to remind you how even we can use the serial, we can do something like that. No need to always have LED to see on and off. You can send some message and generate some message even with the help of interrupt, which is one of the powerful and nice um, ability that we have in our Arduino board. This is checking two interrupt at the same time, which it's good. I put this for your example. Okay, remember or summary of today is that interrupts are a simple way to make your system more responsive to time-sensitive tasks. They also have the added benefits of freeing up your main loop to focus on some primary tasks in the system. The example shown here is just about the most basic case that we can have. We can use reading of I2C device sending or receiving wirelessing data and starting and stopping the motor. And there are some other ways to interrupt to implement the interrupts, specifically by using the resistor and register mask, which can be enabled. Now we don't know that method. We just want to review this method. Okay. As I tell you, today lecture is not much more, but we have we should learn um, more uh, seriously about this lecture, means that interrupt task. Please do and send this task for me on time, and try to send before Monday lecture for me on email. Again, you should simulate them and send it back for me. I will check and give you the feedback for this. And if you had more question, you can ask me. For today, we don't have any clips of application of Arduino. Maybe for next lecture, I will prepare some for you. Then you can enjoy. Okay, if you don't have any question,